guys, welcome to this video on interpolation. So in this video we are going to be looking at the fourth type of interpolation as highlighted in the first video, which is the binomial expansion method of interpolation. So let's consider this question to explain this concept. The question says, suppose a polynomial of degree 4 has the following table of values. Find the missing values. Okay, so I said in the previous video that we employ usually the binomial expansion method to solving for missing values on the table. So we observe that here we have missing values of y. Okay, let's label this accordingly. So we said that the very first value of x is termed as x0. The second value is x1. This is x2, x3, x4, x5, x6, and x7. Similarly, the values of y, first value is y0. This is y1, y2, y3, y4, y5, y6, and y7. So you observe that y5, y6, and y7 are missing, and we need to find this value. So we simply employ the binomial expansion method. Now, by formula, I said the binomial expansion method is given as y minus 1 to the power of n equal to 0, where n indicates the total number of known values of y. So in this case, f of x is also the same as y, right? So how many known values of f of x, or how many values of y do we have? We have 1, 2, 3, 4, 5 known values of y. So which means n. So this simply implies that n is equal to what? 5. So we simply have y minus 1 to the power of n becomes y minus 1 to the power of 5 equal to 0. Okay, we have to now expand y minus 1 to the power of 5 using the binomial triangle or the Pascal's triangle. So let's expand this now. By expansion, we have for the fifth power, this will give us 1. We know 1, 1, basic stuff. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and finally we have 1, 5, 10, 10, 5, 1. So this is actually the value we are using for the fifth power of from the Pascal's triangle. So we are simply going to be making use of this value 1, 5, 10, 10, 5, 1 for our Pascal's triangle expansion. Now we want to expand y minus 1 to the power of 5 using this value. So we start from 1. So you pick out 1. Okay. So you pick out 1. Okay. Now y starts from the highest power, y to the power of 5, multiplied by negative 1 to the power of 0. Negative 1 start from the lowest power as possible. So you have negative 1 to the power of 0 plus. Now we move to the next value, which is 5. You pull down 5. Y will decrease by 1. This becomes y to the power of 4. Negative 1 will increase by 1 to the power of 1 plus. Now we'll move to the next value, which is 10. You have 10. Y again will reduce by 1. This becomes y to the power of 3. Negative 1 will increase by 1. Now it becomes 2. Over here it was 1. Now it is 2 plus. We move to the next value, which is 10. So you have 10. Y will drop by 1. So this becomes, over here, y is 3. So this becomes y squared. Negative 1 will now increase by 1. Becomes 3 plus. Okay, now we have the next, we'll move to the next value, which is 5. So plus 5. Again, y will drop by 1, which simply is y to the power of 1. Negative 1 will increase by 1, which is negative 1 to the power of 4. Okay. And finally, the last number there is 1. So plus 1. Y will reduce again by 1, which is y to the power of 0. Okay, negative 1 will increase by 1, which is negative 1 to the power of 5, and you have this. So let's rearrange this equation and see. Now I have negative 1 to the power of 0, that is 1. 1 times 1 here is 1. So I have y to the power of 5. So we start with y to the power of 5 plus. Now I have y to the power of 4. Negative 1 to the power of 1, please, is negative, right? Negative 1 to the power of 1 is negative 1. Negative 1 times 5 gives us negative 5. So we have negative 5 y to the power of 4 plus. Now I have y. Now I have negative 1 to the power of 2, that is positive 1. Positive 1 times 10 y to the power of 3, that gives us plus 10 y 3. Again, I have negative 1 to the power of 3, which is negative 1, multiplied by 10 y squared. That simply gives us negative 10 y squared. Again, I have negative 1 to the power of 4, that is positive 1, multiplied by 5y to the power of 1. That simply gives us plus 5y to the power of 1. Finally, over here, I have negative 1 to the power of 5, which is negative 1, multiplies 1 here, becomes negative 1 y to the power of 0. So that becomes negative 1 times y to the power of 0. That's negative y to the power of 0. And the whole of this is equal to 0. So remember, y minus 1 to the power of 5 is equal to 0. That's the binomial expansion formula, as can be stated over here. Okay, so having known this now, it means, let's rewrite this equation a little bit. So the equation becomes y to the power of 5. Of course, this is negative 5y to the power of 4 plus 10y to the power of 3 minus 10y to the power of 2 plus 5y to the power of 1 minus y to the power of 0. This is equal to 0. So using the binomial expansion method, this is what you do. You bring down these powers and make them base, right? Or subscripts. So instead of y to the power of 5, it becomes y5 minus 5y4 plus 10y3 minus 10y2 plus 5y1 minus y naught or y0, and this is equal to 0. So with this, you replace all the values of the initials from the table. Y5 is unknown from the table. Okay, y5 is unknown from the table. We are looking for y5, but we know what y4 is from the table. Y4 was given here as 1. We know what y3 is. Y3 was given from the table as negative 1. We know what y2 is. Y2 is 1. We know what y1 is. Y1 is negative 1. We know what y0 is. Y0 is simply 1. So we plug in these values into the equation and find the value of y5. It's as simple as this. Okay, so that becomes y5, which is unknown, minus, now we have 5y4, and y4 is equal to 1. So this gives us 5 times 1 plus 10y3, 10y3, and y3 is simply given as negative 1. So 10 multiplies negative 1 minus 10 y2, and y2 is simply given as 1, so multiply by 1. So 10 times 1 plus 5 y1, and y1 is given as negative 1, multiply by negative 1. Okay, finally minus y0, and y0 itself is given as 1, so multiply by 1, and this is equal to 0. Okay, so now we evaluate y5 minus 5 times 1 is minus 5. 10 times negative 1 is minus 10. Minus 10 times 1 is minus 10. 5 times negative 1 is minus 5. Then we'll have negative 1 here. This is equal to 0. So this simply implies y5. So we have y5 minus 5 minus 10 minus 10 minus 5 minus 1 to be equal to 0. So this simply implies y5. Now let's add up this. Negative 5 minus 10, that's negative 15, minus 10, that's negative 25, minus 5, that's negative 30, minus 1, that's negative 31. So you have y5 minus 31 to be equal to 0. So this simply implies that the value of y5 is actually equal to, send negative 31 over here, you have 31. So the value of y5 is 31. Okay. Now we need to find, accordingly, we need to find y6. Let's pull back the table and see. So we know what y5 is now. We need to find y6, not forgetting our base equation. So this is our base equation, y5 minus 5y4 plus 10y3 minus 10y2. So this is our base equation, y5 minus 5y4 plus 10y3 minus 10y2 plus 5y1 minus y0 equal to 0. So for the binomial expansion, we obtained 1, 1, 5, 10, 10, 5, 1. This is what we obtained for the binomial expansion. So we are changing these values of y in between 1, 5, 10, 10, 5, 1. Okay, let's pull out this value. So our binomial expansion gave us 1, 5, 10, 10, and 5, 1. This is what we had in our binomial expansion. So we are interchanging the different values of y between this binomial expansion value. Now, if you take a look at the table, okay, we looked for y5. Now we want to find y6. What you simply do is you start from y6 and count down, just like you started from here, y5, and you counted down to y0, and it must be between 1, 5, 10, 10, 5, 1. So it mustn't exceed 1 and 1 here. It must be between this total of numbers, right? So since you're looking for y6, you simply start counting down from y6, y5, y4 until it matches this total number of the binomial expansion. Now let's see how that works. So we want to start from y6 now. It becomes y6. So you start from 1, okay? So it becomes 1 y6. So you have 1 y6, okay, minus, and not forgetting from here, this is y5 minus 5y4. So you also impute these signs. So you interchange from negative, positive, negative, positive, negative, and so on, right? So after y5, now we are calling y5 y6. We improve from 1, so it becomes y6. Then you step down. So you have y1 y6. So you start from negative, it becomes 5, negative 5, okay. This becomes now y5. Now after negative is plus, so you have plus, okay, plus 10. Now you step down y5 to y4, it becomes y4. After positive is negative, again minus. The next number there is 10, so minus 10. Now you step down y4 to y3, okay. Next is what? Positive, so plus. The next number there is 5, so you have plus 5. Okay, we step down now to y2. Okay, next number should be negative, so you have minus, okay, okay, next sign should be negative, then you have 1, so becomes minus 1. After y2, your next is y1, and this is equal to 0. So you end here, since the binomial expansion number ends at 1, so it starts from 1 and it ends at 1, you stop. So in the previous case, when we started from y5, okay, it ended at y0 because it has to maintain the number from 1 to 1 as well. So this is also the same thing. So you start from 1, it must end between the binomial expansion number 1, 5, 5, 1, 5, 10, 10, 5, 1, right? Okay, so we simply have this. Now let's plug in these values into the formula. Now we are looking for y6. So 1 times y6 obviously is y6. You pick it out, you have y6 minus 5 times y5. We already obtained a value for y5 here as 31. So it becomes 5 times 31 plus, okay, 10 times y4. So we'll take a look at the table and find the value of y4. So if you look through the table, you find out that y4 is simply equal to 1. So it becomes 10 times 1, okay, minus 10 times. Now you find y3 from the table. Again, y3 is given in the table as negative 1, okay. Y3 is simply negative 1. So you plug in the value as negative 1 plus 5y2. So we'll pull up the table again. This is our y2. Y2 was given in the table as 1. So it becomes 5 times 1, okay, minus 1 times, okay, 1 times y1. So let's take a look at the table again. Y1 was given in the table as negative 1. So you have times negative 1, and the whole of this is equal to 0. Okay, so y6 minus 5 times 31. So let's obtain 5 times 31. So 5 times 31 simply gives us 155. So we have y6 minus 155. Now 10 times, so 10, please guys, sorry, y4 should be 1 and not 10. Let's take a look at the table again. So y4 is actually 1 and not 10. All right, so pardon me for that error. So you have plus 10 times 1, which simply gives us plus 10. Okay, now you have minus 10 times negative 1. Minus times minus is plus. 10 times 1 itself is 10. Then you have plus 5 times 1. That simply gives us plus 5. Now you have negative 1 times negative 1. That simply gives us positive 1. And this is going to be equal to 0. So this simply implies that y6. So let's evaluate this and see. Minus 155, okay, plus 10, minus 155 plus 10, plus 10 again. So you have plus 10 again, plus 5 plus 1, plus 5 plus 1. This simply gives us negative 129 equals 0. So this simply implies that the value of y6 is simply going to be equal to, send negative 129 over to this side of the equation, it becomes positive. So y6 is equal to 129, and that's the value of y6. Okay, now having found the value of y6, let's pull back the table, and we know y6. Now we need to find y7. So we still maintain the same order. It must be 1 5 10 10 5 1. Not forgetting the sign must be positive negative positive negative positive and negative. So it must still be between 1 5 10 10 5 1. Now you're dropping down from y7. Okay, in order to find y7, you start from y7, then you drop down to y6, y5, and so on. So let's see what that gives us. So we want to find y7. We maintain the same number 1 5 10 10 5 1. So you start from 1. Okay, you start from 1, y7. Okay, 1 y7. Okay, remember, minus, then you start from the next. The next there is 5 minus 5. Then you move to y6. Next is going to be positive, plus. Now you move straight to 10. So plus 10. This becomes y5. Okay, now it's going to be minus. The next number there is 10. So minus 10. Then you move to y4. Okay, next is plus, and the next number there is 5, so plus 5. Now you drop down to y3. Next there is negative. Then the next number there is 1, so minus 1, and you have y2 equals 0. So you see, it must be between 1, 5, 10, 10, 5, 1. Then you drop the numbers of the value of y you're looking for. So you see, this now is y7, y6, y5, y4, y3, and it ends at y2. So let's plug in these values and see. So the first is 1. 1 times y7. Y7 is unknown. So you have 1 times y7 unknown. Okay. Minus. Next number there is 5. So you have 5 times y6. And we just obtained the value of y6 as 129. So that is 5 times 129 plus. Next number there is 10. That is 10 times y5, and we obtained y5 earlier as 31. So you have 10 times 31. Okay. Next number there, you have minus 10. Next number there is 10 times y4, and y4 itself from the table, y4 is equal to 1. This is our y4, and it's giving us 1. Okay, so you have 10 times 1. Okay, plus. Now you have 5 times y3. So the number there is 5 times y3. Y3 in the table is given as negative 1. So let's confirm that. So this is y4. This is y4. This is y3, and y3 is negative 1. Mind you, y2 is positive 1, right? Okay. So next we have minus 1 times, so 1 times y2, and y2 is negative 1. The whole of this is equal to 0. So let's evaluate this. 1 times y7 gives us y7. Okay, now we find minus 5 multiplies 129. So minus 5 multiplies 129 gives us minus 645. Gives us minus 645 plus, now 10 times 31, this gives us 310. Minus 10 times 1 is minus 10. Okay. 5 times minus 1 is minus 5. Minus 1 times minus 1 simply gives us positive 1. All right, guys, there's a little error. Y2 is actually positive 1, okay, and not negative 1. Please, let's pull back the table. Y2 is positive 1 and not negative 1. So please, let's just correct that. Y2 is positive 1. So negative 1 times positive 1, this will give us a negative 1. This will give us a negative value. So negative 1 times positive 1 gives us negative 1. So we have this. Now this is going to be equal to 0. So this simply implies, let's see what we have. Y7, okay. Now we find minus 645 plus 310, okay, minus 10 minus 5. So minus 10 minus 5, then you have minus 1. Minus 1, this simply gives us minus 351. So this gives us minus 351, and this is equal to 0. So from here, this simply implies that we can make y7 subject. Y7 is simply going to be sent minus 351 over here. It becomes 351, and this is the value of y7. All right, guys, so that's how you employ the binomial expansion method to find the missing values in interpolation. I will see you in the next video with more questions on this. For more videos on numerical methods, do where to look at the playlist at the end of your screen. Thanks.